Okay, so here's the inequality problem that we're talking about, and when you have a quadratic inequality like this, you want to start by getting the whole thing compared to 0. So right now it's compared to 1, I want it compared to 0. So I square out this binomial, and then I subtract the 1, and now I have the inequality that I really want to work with, right? And this inequality is going to be true for some values of x and possibly false for other values of x. And to figure out what those values are, I'm going to start by finding the critical points. I'm going to find that by factoring and setting each of these factors equal to 0. So that tells me that x equals 3 and x equals 1 are the critical points. Those critical points are the spot where this equation, this left side of the inequality, could change from either positive to negative or negative to positive. So what I want to do here is come up with some test values to sort of test what's happening in each interval. So one interval is to go all the way from negative infinity up to 1. Another interval is to go from 1 up to 3. And then finally I can go from 3 to infinity. So these two critical points divide the whole real line into 3 different sections. And so my goal is to say what's happening here in each of these 3 sections. So I'm just going to pick like a test point. And this may be like a tiny bit different than the way the book is approaching it or talking you through it, but it's very much the same idea. So I'm going to pick a value of 0, which is in this interval from minus infinity to 1. And when I plug 0 into this equation or inequality, I get negative 3 times negative 1, which is 3. And 3 is certainly bigger than or equal to 0. So all the values in here, every x value I pick between minus infinity and 1 is going to be bigger than or equal to 0. If I pick a value here like 2 and plug it in here, I'm going to get 2 minus 3, which is minus 1, times 2 minus 1, which is 1. So minus 1 times 1 is negative 1, which is less than or equal to 0. And finally, if I check over here, I can pick a value like 10. You can pick anything you want in the interval. And when I plug that in, 10 minus 3 is 7, 10 minus 1 is 9. 7 times 9 is certainly bigger than or equal to 0. And so I go back then and take a look at my inequality. I'm interested in where this function is bigger than or equal to 0. So that tells me it's on these 2 locations. Now, you'll notice that it's strictly bigger than 0 on these intervals, but I'm interested in where it's bigger than or equal to 0, and I should be a little more careful there. I can guarantee that it's going to be strictly bigger than or strictly less than 0 on those intervals. The only places it is 0 is at 1 and 3, because those are the critical points. So my solution then should be minus infinity to 1, and then also I should have this interval from 3 to infinity. So that's kind of a way of approaching this quadratic inequality. You want to figure out how to break up the interval, and then you just want to test to see what's happening at one point on the interval. That'll tell you what's happening on the whole interval, and then I know which of those intervals is going to solve my inequality.